Welcome to the third module of Soapui training. In this training, I'll be starting with little advanced concepts of Groovy. Right now, the best way actually to learn Groovy is from this particular website, uh, groovy.sql.Sql, and out here you have got documentation in Groovy. A lot of things actually out here on this website about Groovy, things which are not required in Soapui as well are there. It's a complete end-to-end Groovy tutorial website. You can go into the documentation and you can read about it. Right. Today, what I'm going to start about is I'm going to start about with the object-oriented concepts in the Groovy language. Fine. Now, if I go back to SoapUI and if I create a new SoapUI project and name it module 3, right? And inside module 3, I'll create a new test suite and then a new test case. And under a test case, as I had told you earlier, you can create many kinds of test steps, and right now we are talking about the Groovy scripting part. Okay. Later on we'll see all these test steps and all. So I'll talk about Groovy script and I create a new Groovy script over here. Fine. You can rename this by simply pressing F2 and you can rename it, right? So I'll just rename this script to intro. Okay, now we had seen earlier that using log.info you can print anything in Groovy, and if you run this it gets printed in the logs. Now in this particular Groovy script you can also make a class. Like you'll come to know very soon what class is, how it looks like. Fine. You basically have to make a class like this. For example, class, I'll name my class as say planets, right? So this is a class called planets, and inside this class I can keep lot of variables and functions. Just accept things as they are for some time. You'll come to know what am I doing, right? So for example, let's talk about variables. There can be two kinds of variables in this class. If I write over here define name, so this is one variable name, and if I write define say shape, this is another variable shape inside the class planet. So this is the class planet, right, or a single planet, yeah, that will do. It's got a name and shape. Look, the whole thing will look very similar to Java language. If you know Java, then the whole thing will look very similar to Java. Java tutorials are also available in this course. In the coming modules, Java tutorials are there. If you can watch them before Groovy, that will really help you out. Okay. Now, this class is having simply two variables inside it. Fine. Now there is something like there is something known as creating objects of a class. Okay, because if you have to use this class, you'll have to do something, right? We use the class by creating the objects of a class. We use class by creating objects of a class. For example, we create the object of the planet class like this. Planet P1 equals to new planet. By writing this, I create the object of this class. Fine. Basically, if you comment out this part, if you remove that, then also I'm creating a new object. What do you mean by new object? By saying new object out here in the memory, an object of the planet class will be formed. Inside it, name and shape variables will be there. But to access this object, you need a reference. I have to write like this: planet p1 equals to new planet. So what happens in the memory if I write like this is that there will be a object reference p1 pointing towards this object. Okay. Similarly, I can create another object of this class, say p2, and another object, say p3. The concept is same as the concept of any other programming object-oriented language. Right? Groovy is also object-oriented, so that's why I'm going over to object-oriented concepts now. Right? So now what happens is that 3 objects of this class are created. All 3 will have the variables name and shape inside them. Right? So this would be p1, p2 and p3. p1, p2 and p3 are not objects, they are pointers, or there are references which are actually pointing towards the objects. Okay. Now if I write on the next line p1 dot name is earth, p2 dot name is Jupiter, and p3 dot name is Mars. So p1, p2 and p3 will be 3 planets with 3 different names. Right? Now if I write over here log.info p1 dot name, log.info p2 dot name, and log.info p3 dot name. So names of the 3 planets will be printed. Remember, this class is separate. This is just the individual entity. This is the scope of the class. It starts with this bracket, ends with this bracket. Out here I am using this class. I am creating the objects of this class. I am initializing the objects over here, right? So when you run this thing now, if you look at it in the output, you will see that Earth, Jupiter and Mars are printed, which are the names of the planets p1, p2 and p3. Okay, so this is basically what an object is. There is just one class with one set of variables, name and shape, but practically what I am doing here, I am duplicating those variables in the memory with the help of objects. Every planet will have a different name and shape. Right? Now if you want to initialize the shape, you can also initialize the shape. You can write p1 dot shape is circle. Similarly, p2 dot shape is circle, and similarly p3 dot shape is circle. So all the 3 planets will have the shape as circle. So I end up initializing p1, p2 as well as p3 out here and print the names. Fine. Now if you have to print the shape, then you can also write p1 dot name plus some blank space plus p1 dot shape. You can write like this: p2, p3. So if you run this, this will simply print Earth circle, Jupiter circle, Mars circle, everything will be printed like this. Right. Now out here in the memory, the whole scenario is looking like this. P1, P2 and P3 are three object references. Now the beauty is that I can make P1, I can remove P1 from this object and I can make P1 point towards the second object as well. All I need to do is that I just need to write P1 equals to P2. When I write P1 equals to P2, P1 simply removes its location. It simply removes itself from the first object and starts pointing towards the same object where P2 is pointing. And now if I print this thing, before that I'll just write log.info some star, and if I run this, this prints a Jupyter circle 2 times. Why? Because P1 is now pointing towards the place where P2 is pointing, that is Jupyter, right? So this name out here is Jupyter. This name out here is Earth. This name out here is Mars. So P1 and P2 both point towards Jupyter. Fine. Now this is how you can make the object references move from one object to another object. Objects, they are static in memory. That means they are at a common location. They are at a fixed location. These locations cannot be changed. But the object references, they can be changed from one position to another. Right. Now, if P1 changes the state, if I write P1 dot name is Pluto, P1 is pointing towards the location where P2 is pointing. Right. P2 is saying that the name of the star or the name of the planet is P2. So now P1 changes the name to, it removes Jupyter, it changes the name to Pluto. So for P2 as well, the updated name will come up. So if I write this thing again over here, for both P1 and P2, for both these lines, this will be printing Pluto. Double slash is comment. That means this will be ignored. Right, Pluto and Pluto. This will not be executed. This is just a comment for my understanding. If you keep something in front of double slash, so when you run this, it prints Pluto for both the things. Earlier it was printing Jupyter. So one object can have multiple object references, like this P1 and P2 are object references to this one object. Okay, and secondly, if one object reference changes the state of the object, it gets changed for all the object references. Okay, so this is what I mean to tell you, right? This is what the objects they mean. Objects are like we can say a photocopy of the class, of all the elements of the class, right? And you can create as many objects of the class as you want. Fine. Now in this case out here, this class planet, right, has got a variable called shape. Now all the planets would have the same shape. So it really doesn't make any sense to have the shape variable inside every object when we know that all the objects will be having the same shape, that is circle. All the planets would be circular. It makes no sense to keep shape inside every planet because this every planet has the shape as circle. So what we do is that we remove, hold on, we remove this from here. We remove the shape variable from the object and we keep it at a common location in the memory out here somewhere, and all the objects they can access the shape from that common location. We do it by simply saying out here define static shape. We make the shape static. What happens by defining it static is that shape will no longer be the part of the object. So you can comment these 3 lines and you can directly write planet dot shape is circle. So what happens is that for all the 3 objects or for all the objects which we will create, for all the objects the shape will be a circle. By writing static in front of the shape variable, I am making this variable common for all the objects. But the name is not static, so it will not be common for all the objects. Name will be present inside every object. Okay, so basically there is a planet class. It's got this variable. This variable is known as non-static variable, and this variable is known as static variable. Non-static variable will have a copy in every object, right? It will have a copy in P1, P2, P3. It will have a copy in every object, but the static variable, fine, it will be common for all the objects, and you can access the static variable with the class name dot the static variable. I cannot write like this, planet dot name is say Pluto. I cannot write like this because name is a non-static variable. Name, which planet? Basically, which planet? Do I mean to say that all the planets have the name Pluto? No. So the name variable has to be accessed with p1 dot or the object reference dot. So you cannot write it like this for non-static. This is illegal. But for static stuff, you can directly access it with the help of the class dot the static variable. Okay, right? Please practice this thing, and please open your Soapui and write the code which I am making. Then only you will come to understand. You have to write it, you have to fill the code, you have to tweak it as per your understanding, and only then you will understand it. If you're just watching this like a movie, it will never be, you will never be able to understand it. Okay, now this is the class planet. Fine. In this class I can make a function. I can make a function like public void print name, and in this planet function print name, this is again a this is again a non-static function, right? And I'll make another function called public static void. What is void? I'll tell you in some time. What is public? Public means it can be accessed from anywhere and even outside the class, right? I am writing public static void print or say revolve. In this I'll write log.info planet revolving, and in this I'll write log.info, and I'll just print the name. Okay, right? Now this is a non-static function and this is a static function. All the planets have a common property that they all revolve. So I am making this function static. So stuff which is common for all the objects, you will make it static. But every object has a different name. So print name function will be non-static. So what will happen is that in the memory, if I have an object like this, in this object name and print name would be present. Similarly, if I have another object, in this object as well the name variable and print name function will be present. Object is nothing but object contains all the non-static things, non-static variables and non-static functions, both will be present. But the static things will be lying at a common location in the memory, out here somewhere. Okay, and inside this static you will have shape, variable and revolve function. This static variable and function would be common for every object. No matter if I create 1000 objects, all of them would be having these properties. So whatever is common to objects, you keep them static. Alright, now if I want to print the name, I can write p1 dot print name. The static non-static has to be called with non-static has to be called with reference. P1 is the object reference, right? And if you run this, you will see that, hold on, you clear this, and if you run this, you see that there is a compilation error, right? Script 10 line number 53 unexpected token. Okay, I did not close this. Anyways, if I run this now, I again get an error on line number 52. A parent variable log was found in a static scope but doesn't refer a local variable. Basically the thing is, I'll tell you, it's not able to identify what log.info is. Right, in this script is invoked by default with log, but inside the class planet, okay, inside the class planet log cannot be resolved. That's why it's giving you an error, because the log is present outside this class, but inside this class is something like a closed scope, bracket opens, bracket closed in the end, and inside this class the log variable, it cannot be recognized. So to recognize the log variable, we'll make a global variable called define static log, and out here in the very beginning we'll write planet dot log is equal to log. Now what am I doing over here? Suppose in this I make a variable called print stuff.